Good morning. We're going to be talking about 1.5 application, design, and measurement, where we just kind of have some irregular word problems. All these word problems are going to be slightly different, but they all are going to use the skills that we've built up so far. So this first example, we have a goat. It's tied up to the corner of a barn with a 50-foot rope. The barn measures 60 feet by 40 feet. We want to calculate the total area outside of the barn that is available to the goat. So a couple things to kind of keep in mind here. This rope is kind of like a leash, right? The furthest this goat can get from that corner where it's attached is the distance of the rope, right? Of course, the goat can be here because the rope doesn't have to be kind of taut all the time. It has to be tight all the time. So all of this area for sure is available to that goat. Now, to figure out the total area, we do want to figure out, okay, where can the goat go? Well, that rope is 50 feet long. So let's take a look. If we moved the rope, right, with the goat and went 50 feet as far as we could in this direction, right? If we went as far as we could in this direction, this here would be 50 feet. We wouldn't pass the side of the building because the building's 60 feet long, but we can get all the way to this 50-foot point. Oops. Hold up. There we go. Okay. Now notice, as I was drawing or moving this line here, to get there, that rope can be super tight the whole time. And I could get all the way over here. Now, the shape that I just kind of traced out is like a circle. It's because the goat's leash kind of acts like a radius. That's a terrible circle. Let's see what we can do. And the goat can travel along that circle with that leash. Now, same idea can go in the opposite direction, or the upwards direction. We have the building here. It can also go 50 feet this way. And I could continue on this circle. This time, though, this time, though, the goat's leash is actually longer than the side of the building, right? So let's just talk about what we have so far. So far, if we just consider where the goat can go, from left until the right as far as possible, without kind of considering what's happening over here, we can see we kind of have a 3/4 of a large circle. Right, we can go all of this direction. The goat could go anywhere within this circle because the rope doesn't have to be tight all the time. So we've got 3/4 of this really big circle. Now here's the thing. On this edge here, the goat's leash would be stopped. It can't go any further this way because there is a wall in the way. There's something different going on at the top. Now at the top, past the wall, right? Because if the wall's 40 feet, the goat leash is 50 feet, then it goes 10 feet past. You okay with that? Now, this gray square, or this gray rectangle, is a building. So if I want to go further this way to the left, that rope is kind of hooked on the edge of the building. Now, let's pick a color. That rope can't go through because of the building. But that corner of the building kind of creates another pivot. So this 10 feet that it could have traveled also kind of rotate from this pivot point to also get all of this area here. So As we talk about this example, before we do any calculations, we notice we have kind of two separate calculations we might have to do. We have this first one, right, that is this shape here. I have not quite a full circle, but I have 3/4 of that circle. So part of my area calculation here is going to be to find the area of the large circle, but there's only 3/4 of that circle here. So that blue part that was just highlighted can be calculated by going 3/4 of a large circle. Now this is very similar to the example that we would have had in that skills review, right? Anytime we have 3/4 of something, of in math implies multiplication. So if I want to find that area, I'm just going to multiply 3/4 by the area of that large circle. So pi radius, I'm going to just use a little subscript, capital L for large, and that is squared. Now before we actually do the calculation, I also have this other small section here. The small section's also kind of circular, there's that pivot point, but I only have 1/4 of that. So I have 1/4 area of a small circle. And it's going to be the same kind of calculation here, except 1/4 rather than 3/4. Pi r, and then my radius is a small radius here, squared. Now, size of the radius. So the big circle here, my leash was, or my goat's leash, was 50 feet long. So my radius on the top one's going to be 50. When I take a look at that quarter circle near the top, well, I know 40 is this long from here to here. So that remaining of 10 is going to be my radius of that small circle. Once I get those two values, I'm simply going to add them together. All right, let's plug in and get those numbers. So 3/4 times pi 50 squared. And I could get this as a decimal. I could get this as an exact value of pi. To get it as an exact value of pi, I'm essentially doing all of the math except multiplying by pi. So I'm essentially going 50 squared and multiplying by 3/4. If I do that, I get 1,875, and it's still being times by pi. If I'm looking at my units are in feet squared. Of course, you could plug that in and get the decimal version. You should get an answer close-ish to 6,000, but not quite 6,000. So like probably closer to, I don't know, 5,800, 5,900, right? Something in around there if I had to estimate. Okay, for the second one, I'm plugging in my radius. This time my radius of my small is going to be 10. And I go ahead and do that same calculation. I could plug it in to get the decimal, or I could get that exact value of pi. That exact value of pi here is going to be 25 pi. Again, feet squared. The reason I'm not doing decimals is just it's going to be making my life a little bit easier when I'm calculating the total area when I add those two values together. Right? It's easier for me to write down 1875 pi plus 25 pi to get that final answer. I can combine pi's if I wish, get a more exact step as well, but I can also just plug that straight into my calculator. And if I'm rounding to 2 decimal places, because it doesn't state otherwise, I have 5,969.03 feet squared. And that there is my final answer. Okay, that is question number 1 with our goat. Question number 2, very kind of similar to what we did yesterday with the redecorating of the classroom, except it's a little bit of a shorter question, because in this question, we have 1 can of paint we know can cover an area of 350 square feet. Easy peasy. That's similar to the question, what we said last time was 1,500 square feet. And I want to know how many cans we need to purchase if We want to paint a 50-foot by 10-foot wall, so a nice little rectangle here. 50 feet by 10 feet. And I want to do 2 coats, but the second coat will only require 60% of what is required for the first coat. So this question really is just there to kind of get us to practice calculating extra. So as we go through this, hopefully you're thinking of a couple of different steps. Hopefully you're thinking, okay, I need to find the area of the wall. I need to figure out how many cans of paint are required once I factor in that extra. And that's going to take me 2 steps. Figure out the extra, figure out the number of cans. So I have a total of 3 steps here, and we're going to jump right into it. So my first one is going to be finding the area of that wall. This one should be short and sweet. The area is a rectangle, so I have length times width. And I plug in 50 times 10 to give me 500 square feet. Luckily, the calculation that we did got us into square feet, and the paint is also measured in square feet as how much it can cover. So that's really fantastic. My next step is going to be to account for the extra. So extra paint for coats. Right, we are doing 2 coats, but it was said that the second coat will only require 60%. So extra is kind of calculated very similar to taxes in the sense that my first coat requires 100%. Here's some little side work that I'm going to do. So coat 1 is 100%. Coat 2 is 60%. When I add those percentages, I get 160%. And how I calculate extra is to multiply it by the decimal 160%. So that's really just 1.6. You could also say 1.60. It's also okay. But that's how we're going to do it, right? Taxes-wise, we did something very similar. We paid for 100% plus an extra 12% that goes to the government, which is 112, and that's why we multiplied by 1.12. So here we are. I have the 500 square feet that I know is the area of the wall. I'm going to times by 1.6 to get the total amount of area I'm going to have to cover. And that's 800 square feet. Okay, last but not least, I need to figure out the number of cans required. Number of cans required. And remember yesterday when we were talking about this, we kind of set up the information as a conversion. The number here that I've circled in the question, the 350 square feet, is how much 1 can of paint covers. So I know that if I have 800 square feet and I want to end up with cans, I know that cans have to be at the top, square feet have to be in the bottom so they cancel out. So it tells me really that I'm just having to divide. And 1 can covers 350 square feet. When I plug this in, I get 2.286, blah, blah, blah. That actually might be the whole number. But I know it doesn't really matter about those decimals. I'm about to get to my final answer, and I have to round that final answer. I always have to round up, because if I rounded down to 2, I wouldn't quite have enough paint to cover all of my area. So I need 3 cans rather than 2. If I only got 2, even though typically we would round this number down, I'd have some like gaps of non-painted wall or parts of my wall where maybe I could see through the paint and see that original color. So I'm always rounding up for paint or building supplies. Okay, that was the next question. Next one here. We are going to be talking about rates, and we are going to be talking about a pool. Because Stacy's mom has to empty her cylindrical swimming pool at the lake. There is 5 feet of water left in the pool, which has a diameter of 20 feet. Using a pump that could remove 250 cubic feet of water per hour, How many hours will it take to remove all of the water? Great question. Okay, so as I mentioned before, I'm a visual person, which means I kind of want to see what I'm working with here. So I'm going to kind of draw this pool. Just so I can visualize what's going on here. I know a couple things about this pool. I know there's 5 feet of water. So it doesn't matter how tall the pool is, but I know that the water goes up to 5 feet. That's its depth. Okay. I also know that the pool has a diameter of 20 feet. Now, a couple of things that I need to think of here. Well, in my question, I can see quite clearly that one of the values are in cubic feet, right? Feet cubed. This is a hint that I need to have volume at some point. I mean, volume might have already been obvious to you because I'm talking about how much water can fill this pool, right? Up to its 5 foot mark. So I do need to calculate the volume of the water that I'm starting with. But that's kind of, that unit in the question there is our kind of secondary question, or secondary hint that I need to calculate the volume at some point. We can calculate volume of water in a pool. That's no problem. Volume of water in the pool. We have those volume formulas, of course. So we know that we're dealing with a cylindrical pool. So I use my formula. Volume is equal to the area of the base times the height. Now I'm going to switch out area of the base with something specific to my circle. And I'm going to plug in those numbers. Nothing too crazy. Just plugging in what I have. So for my radius, I've got 10. For my height, I've got 5. I could get that exact value if I wanted to. That ends up being 500 pi. But I could also plug that into my calculator. When I plug that into my calculator, of course I'm going to get something with a butt ton of decimals, and that's A-okay. But we get 1,570 point. I got 796,327 cubic feet. Okay, I made my picture too big. Okay, but I do have another step because the question is asking us how many hours will it take to remove all of the water. So this is the water I have. This is the water I have to start off with. And I want to turn that value into hours. Well, luckily, the question gave us some sort of conversion of cubic feet to hours. Right? It takes 1 hour for every 250 cubic feet of water. So I'm going to set this up just like a unit conversion. So to find the number of hours required, I'm going to start off with that long number, that 1570.796,327 feet squared. I want to get rid of square feet. That has to go on the bottom. And I want to end up with hours at the top. Then I plug in the values I know for that conversion. I know it takes 1 hour to remove 250 cubic feet. And we need to get that answer. Something that's different about this question than the last one is the answer that I get with the decimals. I am able to have decimal time. I do not have to empty things in full hours. I can have decimals of hours, and that's really fine. So when I get that number in my calculator, I'm just going to straight ahead, because it is my final answer, round to 2 decimal places. When I do that, you do it too, but I get 6.28 hours. Okay, couple things I want to talk about. Thing number 1, notice that my hours has a decimal place because part of an hour is allowed. That's totally cool. But this is not 6 hours and 28 minutes. Please be advised. Because in Hours, I'm always basing things out of 60, right? There's 60 minutes in an hour. But 0.28 is not the same as 28 out of the 60, right? 0.28 is like 28 out of 100. So I can never say that this is 6 hours and 28 minutes. That would be an incorrect statement. But I'm okay with leaving it as 6.28 hours. That's the units I would have got from that unit conversion anyways. And I'm more than happy with that. Secondly, although this question, this is the answer, 6.28 hours. It is possible that I could have changed the question up a little bit where I would not have allowed partial hours. And how I could have changed that question is I could have said, you were hiring a company to remove the water from your pool or Stacy's mom's pool. And the company charges for every full hour or charges in only full hour increments. If that was the case, then I would have to round this up to 7 because if I told the company to leave after 6 hours, I still have water at the bottom of that pool. So I'd have to round up to 7 in that instance. Because there's no indication I need to have full units or whole units here, the decimal is A-okay. Okay, last question. Last question is about Haley. She's a young entrepreneur and will be making and canning her homemade pasta sauce to sell at the upcoming farmer's market. The jar she's purchased is shown below. How much? Oh my gosh, it's a soup. Well, sauce is kind of like a soup if you were trying to classify it as soup, salad, or sandwich. This should say sauce. Sorry. Okay, how much sauce can each jar hold if Haley fills the jar 95% of the way to the top? Okay, that little piece is crucial because even when you're filling things, like let's say you're pouring yourself a glass of water, I'm willing to bet that most of you don't fill it so that it's like a little infinity pool in your hands, right? You usually fill it so there's some room to the top, so if you walk from like the fridge or the tap to the chair at the table, you're not spilling everywhere. Okay, so same idea. We need to make sure that this sauce only goes 95% of the way, which is really just useful because we want to make sure that when we are calculating how much sauce can fill the jar, rather than the height being 18, I have 95% of 18 centimeters as my height. Now I could calculate that separately, or I could calculate that within my work. Both are okay. Now if we're talking about how much sauce can each jar hold, then we're talking about the volume, right? Because we're filling jars with sauce. We're not coating jars in sauce. So we need to figure out the volume. Volume, we have a cylinder here. We have the area of the base times height. And that area of the base is a circle, so I'm going to replace it with pi r squared. And we can plug in those numbers. Now, half of 9.5 is 4.75. And 95% of 18 is 17.1. But if I wanted to do that, I'm going to show it with you in my steps here. That's like taking the height and multiplying it by 0.95. Right? Because anytime I multiply by 0 point something, my number is going to get smaller, which is fair because if 18 is 100%, then my number that's 95% has to be a little bit smaller than 18. And again, if it's of the way to the top, of implies multiplication. So that's why I have 18 times 0.95. I'm going to just rewrite that line because some of you might have calculated what 18 times 0.95 would have been. And like I said, you would get 17.1, and that's great. You do not have to show this work. It is not a necessary step. But I wanted to show it just in case we didn't know how to do it. But also, if that maybe makes you feel better to write down the steps as you go, You're welcome to do it either in line with the work or as side work to get that 17.1. Okay, I am going ahead and plugging that into my calculator, rounding to 2 decimal places because it doesn't say to round otherwise, and plug it in. Do it right now. You should get 1,212.09 cubic centimeters. Ta-da! Okay, that's how much sauce can fit in a single jar. Good job, team. Now, when we take a look at the next question, the question says, how much will it cost to make 1 jar of pasta if the ingredients of the sauce are $0.0009, so a fraction of a cent per cubic centimeter, which makes sense because a cubic centimeter is like the size of if you chopped your pinky off at the edge of your nail, right? That's a very, very small amount, which makes sense that it's going to be a fraction of a cent here. And each jar costs 40 cents itself. So we take a look at the cost here. So I have cost of the pasta and I have the cost of the jar. I'm going to add those two costs together. Now, to find the cost of the pasta, right now we only have pasta measured in cubic centimeters. But I am given that conversion. I'm given the conversion from dollars to cubic centimeters, so I can use that value to figure out the cost of the sauce. So cost of sauce. I'm using the rounded value from the previous question because that previous question ended. So I can use that rounded value. It wasn't like a step in a longer question. It was a final answer for previous one. So I'm using that rounded 1212.09 cubic centimeters. I want cubic centimeters to go away, and I want dollars to end up on top because I'm looking for cost. And then I use that kind of conversion given to me in the question. I have 0.0009 for every cubic centimeter, or for every 1 cubic centimeter. And notice this gives me a cost in dollars. So when I do this, dollars is only measured with 2 decimal places. So I want to make sure I'm rounding to 2 decimal places here. When I do that, I should get $1.09. Now remember, this is just the cost of the sauce. I want to know the total cost to make 1 jar. So I need to include the cost of the jar and the cost of the sauce total. So cost of, I'm going to say 1 product. And that's my 2 costs added together. That's my $1.09. And it's my 40 cents to actually just buy the jar. And that's quite nice. My final answer is $1.49 to make 1 jar of that pasta sauce. Okay, our last question of this 3-part question is just how many jars of pasta sauce can be produced for $500? Well, that's a great question. We're going to set this one up also like a conversion. Right? I have $500. It would be great if I knew how much 1 jar cost. But I do. I know that this $1.49 is the cost of 1 jar. And that's so super useful. Hey, you're a highlighter. You're so super useful because if I want to convert $500 to number of jars that can be produced, I want jars to be at the top. And I want dollars to be at the bottom. And I know that 1 jar costs $1.49. And I can go ahead and figure out that number, and that will be the number of jars. When you plug it in, you get that number. Plug it in, see what you get. But I get 335.57 and so on. But I know that I'm not making a fraction of a jar. I can't go to like Dollarama and buy a third of a jar because that's what my budget allows. I have to buy the jars in whole number units. And same idea with sauce, okay? So when I do this, I need to round down. I can't round up because I don't have quite enough money to make or to pay for the next jar. So I need to round down regardless of what that decimal ends with. So I can, for $500, make 335 jars of pasta sauce. Okay, that is it for this lesson. Couple things to kind of keep in mind. Thing number one about this question is I actually didn't have to separate it into 3 chunks. I could have given you this question at the very beginning, given you all of this information, and simply said, determine how many jars of pasta sauce Haley can make for a budget of $500. But sometimes when there's all those steps we have to do in one question, it's easier to break things down. Now, if that was our original question, I'd still have to do all of these steps. I'd still have to figure out how much sauce fits in a jar. I still have to figure out how much it costs to produce 1 jar of sauce before I can do that last step. So please keep in mind that a question like this can really just be lumped into one original question rather than 3 parts. Otherwise, that is it. That is all. Tomorrow, I'm gonna answer any questions that we have about this lesson, and then you'll have time to work on the 1.5 practice. Have a fantastic day, and I will see you tomorrow.